Okay, so let's look at the problem 2-119. The question is like this: determine the projected component of the 80 Newton force acting along the axis AB of the pipe. So we are given a pipe network beginning from point C and passes from point B with an elbow and ends at point A. Okay, so the coordinates are given. So the point B is located 4 meters away on from point C on y-axis, and then it goes to the point A. The point A is 2 meters below the XY plane, as you see from the figure, and it is 7 meters away from the point C. There exists a force acting on point A. It is directed to the z-axis, and this direction ends 12 meters below the c-axis. So let's say that this point is D. Okay, sorry, this is not the one, my mistake. This point is D. Okay, so this point is D. Okay, so now we have the point. So we have points C, B, A, and D. So what we need to do is we have to find the unit vector first from B to A. Also, we have to find the unit vector from A to B. Now, in order to, first thing is we need to write the force F in Cartesian form, okay, as a Cartesian vector. Therefore, we need to find the unit vector from A to D, and then we have to multiply it with the unit vector from B to A. This is what we are going to do. In order to do this, let's begin by writing the position vectors and calculate the unit vectors. So first, RB. RB is equal to 4J. Now, if I look at the RA, RA is equal to 6 I vector plus 7 J vector and minus 2 K vector. That's okay. Now I know the point A, B. So let's write the RD as well here. RD is equal to minus 12 K vector. Now next thing is to calculate the RBA. RBA is equal to RA minus RB. If I do the operation, this is 6i vector plus 3j vector minus 2k vector. Now I can calculate the unit vector from here. UBA is equal to RBA divided by its magnitude. So it is 6i plus 3j minus 2k divided by 7. So the unit vector is 0.86 I vector plus 0.43 j vector minus 0.29 k vector. Okay. Now let's calculate the unit vector from A to D. So UAD will be calculated now. This will be the next thing. In order to do that, I have to calculate the RAD. RAD is equal to RD minus RA. And the result is minus 6 I vector minus 7 j vector minus 10 k vector, and from here we can calculate the UAD as RAD divided by its magnitude and this gives us minus 0.44 I vector minus 0.52 j vector minus 0.74 k vector. Now next thing is to calculate the Cartesian force F in Cartesian form as a Cartesian vector. That is the magnitude of it multiplied by UAD So it is minus 35.2 I vector minus 41.6 J vector minus 59.2 K vector. Now what is asked us is the component of the force in BA, on BA, sorry. So this is what is asked to us. FBA is equal to force F multiplied by scalar multiplication UBA. Now let me write the force vector first. This is minus 35.2 I vector minus 41.6 J vector minus 59.2 K vector multiplied by UBA. I will write it here. So I will continue the expression below. Multiplied by 0.86 I vector plus 0.43 J vector minus 0.29 K vector. Okay, now how I do the multiplication? Now first I will do I multiplied by I. Okay, so minus 35.2 multiplied by 0.86, and the result will be minus 30.272. I multiplied with J is equal to 0. Okay, so because I and J are perpendicular to each other, I multiplied with K is 0. I'm just multiplying the unit vectors first and then multiply their coefficients or their magnitude, the magnitude of the vector in that direction. So this gives me 0. Okay, now let's take the second term in the force vector. So 41.6 minus 41.6. J multiplied with I is 0. J multiplied with J is 1. And then I can multiply their coefficients. 41.6 multiplied by 0.43. So it gives me a value so I multiply a negative value with a positive sign 0.43. Just a moment please. So this is minus 17.8, and now considering the z component, I multiply only with these terms, so minus 59.2 multiplied by minus 0.29, and minus to minus is positive, so this is 17.168. Okay. So these are the values. And the final result, if I do the operation here, it is minus 30.992 unit is newtons.